Describe a sequence of two geometrical transformations that maps the graph of this function onto the graph of this function. Sketch on the axes given below the graph of y equals the modulus of this function, indicating the exact value of the x-coordinate, where the curve meets the x-axis. Solve the equation here, and hence or otherwise solve this inequality. So that's the question then. Here it is in summary form. First of all, y equals log x. So let's have a little look at this. We need to describe this geometrical transformation. So a quick sketch of the log function then. We know it comes up here, don't we? Like so. And there's the value 1. Log of 1 is 0. Here's your x, here's your y. And here's 0. Now, what happens? Well, log x minus e, so the first thing that we need to do to map this onto this function here is, if we look at log of x minus e, this is ln x, and then log x minus e, well, to get that 1, we need 1 plus e here, don't we? 1 plus e, and then we put that x value in there, these will cancel, we'll get log of 1, which is 0. So here's the same graph, but just shifted forwards by e units. So that's a translation. Oops, translation. Forwards by e, not for anything vertical, just moved across. And then finally, to get to our 4 lots of this, we need to stretch it by a factor of 4 along the y-axis vertically. So stretch it, and we times everything by a factor of 4, so it's stretched up. So this is a stretch, by a scale factor. Of 4 along y-axis. So we're stretching it along the y-axis that way and that way by a factor of 4. Okay, that's that then. So that's what we've got for that problem, part A. Okay, that's good. So we've just done that then. Good, that's part A. So part B, sketch the modulus. So we got this function here, and now we can just sketch the modulus now. So I'll do that next with the information in hand. I'll do a proper sketch here for part B. Okay, some straight lines here. And we also need one vertically, don't we? Put one down here. Okay, y-axis, x-axis. And we're basically going to sketch this. So this is the value of 1 plus e, which was the value here. And then we just sketch this curve. I'm using a digital pen, so I'm going to have to use dashed lines if that's okay, because it's difficult to sketch. Like so. And, oh, it's the modulus, isn't it? So these negatives flip to positive, don't they? So we need to draw the positive ones in, like so. And the negative ones, of course, disappear because they become the modulus positive values. So there's the graph. Then part B, specifying where it cuts the x-axis, which we've done here. Part C, solve this equation then, equals 4. Part C, so when does it equal 4? So I'm just going to, for the purposes of the sketch, I'll put it in here. So we should see these values here and here, either side of 1 plus e. So part C then. So this part of the curve will be the negative, and this part will be the positive, won't it? So the negative part of the modulus for ln x minus e is equal to 4, or the positive 4. So that tells us then, move this over, ln x minus e is equal to minus 1, or ln x minus e equals 1. Unwrap the log, x minus e is equal to, the e comes up, e to the minus 1, there's 1 over e, or x minus e is equal to e. So this one here is x is equal to e plus 1 over e. That's the first solution. And the other solution is x equals 2e. So there's the two answers then for part C. Hence solve this equation here. Well, when is this modulus bigger than or equal to 4? Well, it's bigger than or equal to 4 here and here, so it can bigger than or equal, so it can touch this value. So part 2. So here it can go up to oops, I'll get it right in a minute. It's going to be less than and go up to and touch e plus 1 over e. And it can go down to 0. No, it can go down to e, isn't it? Because that's where it's shifted over. So this value here is e. Because this is 0, and when it's shifted over e, there's an asymptote here of e. That's the asymptote there. Okay, so it can only go down to e. Or x will be bigger than or equal to 2e is fine. No restriction on that side.